you can ask, well, if you ask them something like, what is 1 + 1, that doesn't exactly answer our question about where the road leads. So our question has to be something about the road. And one good question to ask would be to say, would this be the road to your home? Right, because basically the city is separated into two sides, the knights and the knaves. And they're saying, like, we need the road that leads to the knights. If you ask a knight, you know, is this your road home? The knight will say yes. And if the answer is, if the answer is yes, the road is to the way to the city of the knights. If they answer no, that is not the right way, then it's leading to the city of knaves, the other direction. So a little convoluted, but also, like I said, not exactly a Hunter question. The reason why it applies to Hunter and why it's a good question to study anyway is primarily because it helps us sort of decipher this complicated language that many Hunter questions ask. Sometimes there is a lot of details and longer paragraphs that we have to piece out the information from, and this is a good way to sort of get used to these things. The next question was 23. Each of the cards shown below has a number on one side and the letter on the other. How many cards must be turned over in order to prove the correctness of the statement? Every card with a vowel on one side has a prime number on the other side. And the answer was 5 cards. The logic behind this is that to grant that something is true, to grant that a statement is true, we have to prove that both the statement is true and the opposite, or the contrapositive is what we call it, must also be true. So we have to prove that every card with a vowel has a prime number. But the contrapositive, or like the flip and reverse of it, is that every card that does not have the prime number does not have a vowel. So we have to turn over every composite number to make sure it also doesn't have a vowel on the backside. Also, not exactly a Hunter question because they don't really talk about contrapositive statements, but nevertheless beneficial to know. So in the first part where we verify that the vowel has a prime number, we have to turn over the vowels. So we turn over A and E. And on the second side, the second half, it says every number without a prime does not have a vowel. So we have to turn over the ones that are not prime, which are 4, 6, and 8. So 2 in the first one, 3 in the second one, and we get a total of 5 cards flipped over. And that would be your answer. All right, any other questions from the math? If not, then let's turn.
I didn't understand most of the math, but one that I really didn't understand was number 22. Number 22.
22, okay.
Yeah.
The traveler has a straight gold chain with 7 links. She plans to stay at an inn and is willing to accept 1 link as payment for 1 night's lodging. She doesn't know when she'll want to leave, so she'll want to pay on a daily basis. She'll have to cut some of the links on her chain. The inn is perfectly willing to accept cut links as payment. What is the smallest number of links she is forced to cut in order that she's able to pay every night? Possibly getting change in the form of links paid earlier for up to a week. So the idea is that when you have these 7 circles, what they're saying is for her to be able to pay every day up to a week means she needs to be able to make 1, 2, 3, 4, 5, 6, and 7. Right? So if you cut only the first chain, you cut the first one, you can make one link, right? And then you'll have 6. So this one link can pay for your first day, but how are you going to pay for the second day? You would have to make a second cut. So one way out of this is to each day just keep cutting another link. But that would give us an answer of 7. And the question is asking, what is the least number that she has to cut? So it's not just about how many we cut, it's also about where we cut them. So to be very strategic, we would have to think about, okay, depending on where I cut, I can make different numbers. So for example, if I cut the second link, right, I get 1 and 1, and then I have 5. Now that's not going to help us either. It'll get me to day 2, but then when it comes to day 3, I have to make a third cut. So the best place to make the cut is on the third link. And the reason that is because when I cut the third link, let me try to put it on the board. Let's see, 1. I recommend you draw this in your notebook. So it's 7 of them. Basically, if I cut this third, I can get what? Well, this one will give me a group of 1. Then these 2 on the left from where I cut give me a group of 2. Put them together, I get a group of 3. So I can so far pay for day 1, day 2, day 3. Now day 4, I can just use these 4 links. Then day 5, I can do for the link of 4 and the link of 1. Then day 6, I can use the link with 4 and the one with 2. And then day 7, I could use the one with 3 and the one with 4. So the idea is, if we only cut the third link, we create groups of 1, 2, and 4, which can be combined to make the sum up until 7. Right? We can make any number from 1 to 7 in terms of addition using numbers 1 to 7. All right. Okay. Is there anything else from the math? You can put it in the chat. Otherwise, let's turn our attention to week 1 reading. And someone asked us to review questions 15 and 16.
This is the one that I asked her. The one she reviewed.
Takatul, something is wrong with your microphone. It keeps unmuting. So can you please make sure to mute it? Okay, now correct me if I'm wrong, but question 15 and 16 is asking, according to the passage, the French attitude towards the human development of force is best described as one of blank. And then 16 asks, which choice provides the best evidence? So these are pretty sporadic. Having not read this passage in a long time, I want to show you guys a way that we can sort of approach it without having a complete understanding of the passage. So I look at the answer choices for 15: disdain, pragmatism, ambivalence, and enthusiasm. So first of all, I need to know what each of those words mean. Disdain, we know, is a strong dislike of something. Pragmatism is something, is like an approach that's, assessing the truth, something that's like practical, reasonable, right? Those are good words to be, to address that. Ambivalence, as many of you know, it's where you don't care, right? It doesn't matter either way for you. And enthusiasm is very excited, happy thoughts. So what we're looking to figure out is what kind of attitude these people had towards the development of forests. Now, again, without reading the whole passage, I want to go through each of the lines, each of the answer choices for 16, and see how they can help me. So 9 to 11. The English may cherish rural walks among the green woodlands of their country, but for the most part, their ancient woodlands have been urbanized, as in the case of the New Forest in New Hampshire, where the smells and scents of the countryside have been smothered by the stink of petrol and diesel fumes, or industrialized by the Forestry Commission, as in Northumberland. Okay. Oh, sorry, it's just 9 to 11. I don't know why I read further. So 9 to 11 doesn't talk about, it just talks about what the English may cherish. So it actually doesn't talk about yet what happens in the forest in New Hampshire or the urbanization. So A is a pretty weak answer in that sense. B says 20 to 23. Let's read that. The need for direct communication between towns and cities had meant that roads and high-speed rail lines have been permitted, but these have not been allowed to impose on the land, which is why transit routes are so direct and straight. So assuming that this is the French, well, this is a French author, right, describing what it's like, they're explaining how they're making it work, and they're giving us the reasonable explanation for the communication between the towns, which kind of alludes to the answer of pragmatism. They're being very pragmatic. They set up a line of communication. They are able to all get what they want, right? What they say, that high-speed rail lines have been permitted, but they don't impose on the land, right? Routes are direct and straight. So they're doing things that are supposed to make sense to them. They're trying to find the best middle ground. 61 to 63. Regardless, at any time, without asking anyone's permission, any citizen may enter a French forest and pick the wild fruits and berries and mushrooms. So that doesn't describe any attitude. That's just a blatant fact. And 66 to 67 says they are the national heritage, or as it is called in French, le patrimoine, whatever it is. A short statement, basically a fact, not exactly showing any attitude. One of the things that obviously that we need to focus on is that what the question is asking is an attitude towards development. So it needs to be somewhat of an opinion. The fact, when they give us a fact, that doesn't mean it's ambivalence. It just means we're not looking at the right part of the text. So the only one that seemed to work for us was lines 22 to 23, where they seem to be agreeing that it was a rational and reasonable choice and that they've made the right decision when it comes to the communication between the towns and how to set up the development. So that would allude to answer choice B, pragmatism. So 15 and 16 are therefore both B. All right, what other questions do we have from week 1? Nothing? Put them in the chat if there's anything. All right, if there is nothing, let's move our way on to week 2. So in the chat box as well, please tell us what questions you have from the week 2 math or reading, and be sure to specify which ones. Again, be sure to specify if we're talking about math or reading. And everyone should have their packets out. You guys are jumping far ahead to week 9. What week are you guys up to in class?
We're on week 7.
So how do you
Well, I just finished the week for week 7.
So how can you have questions from week 9 already? Well, we'll try to work our way up to week 8 or so, but we have to start somewhere, and we're gonna start in the beginning. Okay. So from week 2, we're starting with questions 14. We're at whatever you guys are up to in class, we are up to week 2. So, number 14, we have 14, 16, 17, 19, and 20 to go over in week 2. 14 says, 3 natural numbers, A, B, C, satisfy the following conditions. I'm going to try to put more things on the board. It says A plus B is odd. A plus C is even. And A times C is odd. And they're asking us to figure out what must be true, specifically about B, right? You guys catch that? So 1 second, let me pull it up. And it says B must be even, odd, or it doesn't matter. So let's see. How do we get an odd product? Can anyone tell us? Yeah, Wyatt?
Odd plus even or odd plus odd plus odd.
No, I was talking about a product, not a sum. But
Oh, a product.
the odd product is the easiest to get first. Tara, what is it?
Both numbers have to be odd.
Exactly. That's a pretty big restriction. Odd times odd. Oh, sorry. It does say that. A plus B is odd, A plus C is even. So that means that A and C must both be odd. And does that make sense for us? Well, if we have, say, 3 times 5, that's 15. But then what if we add them? Because it says the sum is even. 3 plus 5 is therefore 8, and that is even. So that means that we know that A must be odd then. So then that kind of brings us to B. To get an odd sum, well, what could we do? It could be even plus odd. Could it be odd plus odd? No. Could it be even plus, Could it be even plus even? No, it must be even plus odd. So if A is odd, then B must therefore be even. So the correct answer would be A. B must be even. All right, let's take a minute, make sure you're copying this down in your notebook. The key here is to recall the rules about sums and products, whether or not they're odd or even. The really easy part about this is that regardless of whether or not you memorize them or remember them, it's very easy to figure them out again, right? So if I forget what is odd times odd, pick two numbers in your head, 3 times 5. Oh, that's odd. Same thing with
Miss
the
Dasha,
sum. Yeah.
this question always involves at least a little bit of guesswork. Is it possible to solve this question without any guessing?
We're not doing any guessing here.
Because in the end, once we oh wait, never mind.
Yeah, there's no guessing. We can plug in numbers to help us, but we don't need to, right? What we do need to do is just know the rules about what odd and even multiply and add to. And that's really it. Okay. Okay, the next one is 16. So this one I'm not going to put on the board. You guys have to look at it because it has this pattern here. It says the odd positive integers 1, 3, 5, and 7 are arranged in 5 columns continuing with the pattern shown on the right. Counting from the left, the column in which 1985 appears is blank. So we have 1, 2, 3, 4, 5 columns. And it's a little bit odd or different for us because the columns aren't exactly aligned, right? They shift a little bit. So we can't just divide the number by 4 in the same way that we would. So we look at, okay, when or how often does this pattern repeat? There's 2 ways of doing this. And I would start with, I think the easier one is to say, this pattern repeats or returns to the same place every 8 numbers, right? So 1, 3, 5, 7 is in one row, and then 9, 11, 13, 15 is in the other row. So it kind of like snakes around, right? So each of these snakes happens every 8 numbers. We have to recall that these are all odd numbers. So what we need to do is figure out how many of these loops or patterns of 8 does 1985 go into. And 1985, for starters, is the 993rd odd number. And the way we figure that out is we divide by 2 and add 1, right? That's the easy part. So then we see, then I would divide this pattern by 8, right? The 993, to see how many times it does that snake. And when I divide it, I just did it on my calculator, it becomes 124 and an 8th. So that means we loop around 124 times, and then we go on to the next one. So the remainder one means it becomes the first number in the next row, which means that it is in the same column as the first number in the first row. And 1, the very first number, was not in the first row. It is actually the second row. So we would say it is in row B, right? Think about it. We make each of these loops. We made them, 124 times. So we finished where the 17, the 33, the 49 is, and then it says one more because of the remainder 1. And one more will jump down to the position where the 1 is. So the correct answer there is B. The very same pattern exists in number 17, the very next one. It says the counting numbers are arranged in 4 columns as shown on the right. Under which column will 2012 appear? Now we have to be sure not to fall for the mistake that we almost fell for in the previous one. This pattern also snakes around. It doesn't just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? It loops. So the pattern isn't actually every 4, the pattern is every 8. So when we divide 2012 by 8, we get 251 and a half, which means that we do 251 of these loops, and then we end halfway. So what's halfway of the loop? Well, it's on the rightmost side. So that gives us column D, which means it would be in the position of the 4 or the 12. So the answer is column D. The next one that you guys asked is 19. How many integers among 1, 2, 3 up until 98 can be expressed as the difference of 2 square numbers? Now this is a tricky one, and I would most likely say with most of my confidence that it's not something that would appear on the Hunter test. Give me 1 second, guys. Sorry. So though most of this would not appear on the Hunter test, I do want to just show you the strategy. So a difference of perfect squares would be if we wrote something like m squared minus n squared, right? Does anyone know how we simplify this? Has anyone seen this before? If anyone remembers or was taught how to FOIL, if you know that strategy, this becomes easy. If you don't, this might look confusing. But all we need to remember is that it's the same as m plus n times.
It's times 2m times 2. Oh, never mind.
That's the other one.
Different thing.
You're on the right track, but it's not exactly the same one. This is the difference of perfect squares, which means that it has to be m plus n times m minus n. So if m plus n, therefore, if m plus n is even, then it has to be multiplied by at least, right, the smallest it could be. So it could be then m and m minus n times m plus n must be a multiple of 4. Because the smallest that it could be is 2 and 2. And either way, it will, since they are perfect squares, they have to be a multiple of 4. Now, if it is odd, oops. If m plus n is odd, then what we already talked about was that odd times odd will give us odd. And odd minus odd would also be odd. So then x has to be odd. So what we're really looking for is a number that is either a multiple of 4 or is odd, based on whether or not it could be either either odd or even. So how many odd numbers do we have? Well, it's a little bit less, it's one less than 100, so we have 49 odd numbers. And how many multiples of 4 do we have? Well, if it were 100, then we would have 25 multiples of 4, but since it's one less, it's 24 multiples of 4. So 49 plus 24 gives us 73. Now it's important here that we remember in this case, we don't have to account for any overlap. Why? Because any multiple of 4 is not going to be odd, right? Because every multiple of 4 is also a multiple of 2, so it can't be odd. So that's how we get 73 as our answer here. Again, this is definitely on the trickier side. It's okay if you're having trouble understanding this, the simplification here, but it's important to have this in your notes and basically memorize it, the difference of perfect squares. So if we give you something like, let's say 9, oh, this is question 19 on week 2. So if we say something like 9 plus 3 times 9 minus 3, it might be, you could solve this pretty quickly, but it also would be easier for you to just say it's 81 minus 9. Now, usually we won't see it in this capacity. Usually you'll see it as part of an algebraic equation where you need to simplify it, and this is a quick and easy step to do so. And number 20 is actually asking about the same question here. So I have the same idea. Yeah, this what we just did was question 19 in week 2. The difference of perfect squares between numbers 1 and 98. And the next one we're doing is number 20 in week 2. Number 20 says the sum of a positive integer and 100 is a square number. So let's say x plus 100 equals n, or let's say a squared. Then it says the sum of the positive integer and 168 is also a square number. So we're using the same x and we're doing plus 168 equals b squared. And we have to figure out what x is. Okay. we know that we take what we just learned and we do a squared minus b squared. We'll say that it's the same as a plus b times a minus b. Right, that's what we just wrote out with the n's and the m's. And a squared is n plus 168. Sorry, n plus 100, and then b squared is n plus 16 or x plus 168. And then when we subtract them, we need to put this in parentheses, of course. The x's obviously subtract, and so what we're left with is just 168 minus 100, which gives us 68. If we prime factorize our 68, we get 4 and 17, or 2 and 2 and 17. So what does that mean for us? It means that what does this mean? So it could be like something like 34 times 2. Or it could be, why couldn't it be? Oh, because they have to either be both even or both odd to multiply. Well, actually they have to be both even to multiply to 68. So using the numbers 2, 2, and 17, we multiply them in various ways so that we can get them to multiply to 68. And the way to do that is to do 34 times 2. So basically that says what? That a plus b is 34, and a minus b is 2. And that, I believe that gives us a is 18 and b is 16. So the question asked us, sorry, this is a bit of a complicated problem. I didn't take a chance to look at it, but the positive integer. So we can test it and we should get that x what is the integer? X equals 100. Well, x equals 18 squared, sorry. So x is 156. And then we can check if 156 is right. By doing 156 plus 100, that's 256. And that is 16 squared. And then 156 plus 168, I'll do that on the calculator, is 324. And that is also a square. And that's 18 squared, like we said. Now again, it's a more complicated problem than you will need for the Hunter test. I think the biggest takeaway is, again, just this formula of the a squared minus b squared, and then everything falls in line.
This is week what?
This is week 2, number 20.
Alright. This might be useful, but might not be.
I can't hear what you're saying.
This might be useful, this might not, but my dad told me that when what's a triangle, like the two sides of the triangle, the two shorter sides of the triangle squared multiplied by the longer side of the triangle equals the longer side of the triangle. That only works for right triangles.
How is that relevant to this question?
It's not, I'm just saying.
There is a rule that says that the 2 shortest sides must add up to longer than the third side, if that's what you're referring to. Yes, that is a property of triangles, but it's just not, it does not pertain to this question in particular. But yes, that is a rule of triangles, and that is something that is more likely to be tested. Okay, let's go on. Since you guys are on the wave of math, seems like, let's look forward to, someone asked about week 6. I'm trying to go in chronological order here. And we wanted to go over numbers 19. So let me put that up on the board. So let's turn to week 6 math, number 19. And this is important because it does come up. It says 0.6 repeating plus 0.3 repeating over 0.9 repeating. So we have to find a way to work with these repeating decimals without them scaring us away. Does anyone know what is the rule about repeating decimals? Yeah, Andrew.
So the bar that is over the number gets repeated, like 0.3 and then 6.9 under the bar is basically gonna be 0 and then that number, then 6.9, 6.9, 6.9, 6.9, oh, infinite times.
True.
Can I try?
But what do we do with it? That is what it means. And it just means that it would be like 0.6666 repeating. But how do we work with it? Because we can't add all the infinity. Yeah, Henry?
Can I go? So you'd have to turn them into fractions first. In order to turn them into fractions, you can multiply them by 10 and then subtract it from the original number. If we do this with 0.6, you'd get 6 as the remainder because it's 0.6 times 10 minus 0.6 bar. So you'd get 6 as the remainder. I mean, you'd get 6 as the answer. And then we get the equation of 10 times the decimal minus the decimal equals to 6. And then that could be simplified to 9 times the decimal equals to 6. So then if we divide on both sides, we get the decimal is equal to 6 over 9.
Yes, but you said we have to convert them to a fraction first.
Yeah, so 0, basically put 9 under, basically. So right. 0.6 bar would be 6 over 9, and 0.3 bar would be 3 over 9.
Right.
But we don't really even need to do this. Because you can do mental math and notice that 0.6 bar plus 0.3 bar is 0.9 bar. And 0.9 bar divided by 0.9 bar is 1. So we don't really need to do this at all.
So what you're saying is correct. But I think that what I wanted to get out of here first was how to convert irrational decimals to fractions. And you said it exactly. What we need to do is put it over 9. Whatever the number is, we put it over 9. But yes, you're also right that if we do this math, 0.6 turns into 6 over 9, which becomes 2/3. And then 0.3 becomes 3 over 9, which is 1/3. We add them up, we get 3/3, which is 1. And then with the 0.9 repeating, we get 9 over 9, which is, as we know, also 1. So our final answer is basically 1 over 1, which is 1. So what I want you guys to take away here is that if a decimal has a bar over it, you put the number of spaces over that many 9s. Now I know that might sound complicated, but the way that this becomes a little bit different is if I had, for example, 0.12 repeating. It's not the same as saying 12 over 9, right? We know that that's definitely wrong. It would
In this case, it would be 12 over 99.
99. So if I have 2 digits in the 0.12 repeating, it'll be that many digits of 9, right? That's why I said over that many 9s. So if it's 2 digits, it's 2 9s. If I had let's say if I had 1, 2, 3, it would be over 999. All right, so that's the rule behind that one. So let's copy that down real quick and then we'll go on to the next one. Okay. The next step here is we'll go on to number 20. It says that 1 over 13 is a repeating fraction. It's 0.076923. And this whole thing is repeating. So then it asks us, well, what is 3 over 13? And so numbers like this, fractions with repeating chains, they always cycle. So when we figure out 3 over 13, we don't have to do the whole thing. We have to figure out what number does it start with. And continue the pattern. This will save us a lot of time in questions like this. So if I start with saying 3 over 13, 0, obviously. 13 goes into 30.
Twice.
And so I know now, without having to even find the remainder or go further, I know that this number was going to start with a 0.2. And then we have something, 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 etc. So what we know, based on the chain, we're going to start with this 2. This is the only 2 in in the decimal, and there will never be a number that repeats like that. So the answer would be 0.23 and then 0.769. 230769, and it repeats that way. So pay attention to the shortcut in terms of understanding that we don't need to find the whole thing to figure out the number that it starts with and understand that it's always going to continue to cycle. Now, as you guys finish copying this, I'm going to go on to 21. It's also very similar. It's a 0.7 minus 0.4 plus 0.2, and each of these have that little bar over them. So knowing what we now know, based on what we talked about the rule with the bar, what do? We turn them into fractions by putting each of them over a 9. So it's like saying 7 over 9 minus 4 over 9 plus 2 over 9. So 7 minus 4 is 3 over 9 plus 2 over 9 gives us 5/9. That is it. It says to express it as a common fraction. Well, there's no simplifying 5/9, so we just leave that as our answer. Similarly, 22. 22 is 0.31 plus 0.8, also repeating. So this is where learning that rule that we talked about how many 9s comes in handy. Because remember, 0.31, since there's 2 digits, it's 31 over 99 plus 8 over 9. Notice they have different number of 9s. Of course, we know that to add them, we need to put them under a common denominator. So 31 over 99. To get from 9 to 99, we multiply by 11. So we could say 88 over 99. 31 plus 88 gives us 119. Divided by 99. Now, is that divisible by anything? I don't think so. Oh, no, it is. Well, it's divisible by 7, which doesn't exactly help us. Let's see. No, that's the simplest it gets. That's 22. Then just 2 more here. Make sure we're all copying these down. It says 23. Now this includes multiplication. This says 1.1 repeating times 0.01. So nevertheless, we have to treat it like an irrational decimal. So we put a fraction, turn them into fractions. So this equals 1 and 1/9. And this equals 1 over 100, as we know. So we can say 10 over 9 plus 1 over 100. Oh, not plus, times, my bad. And that does make it easier for us, because we can get 10 over 900, which is 1 over 90. Okay, take a minute, let's copy this down, and then we're going to go into the last one in this week's homework. Questions on any of this so far? Okay, can we go on to the next one? All right, let us know if we need to go back. The next one is 24. It says 0.45 plus 0.54 plus 0.5 plus 0.4. And these two are repeating. So this one and this one. So what do we know? This is going to be 45 over 99. This is 54 over 99. This is 5 over 10, and this is 4 over 10. So the first thing I would do before we put them under a common denominator is add what we already know. So 45 plus 54 gives us 99 over 99. Convenient, right? And this gives us 5 tenths plus 4 tenths gives us 9 tenths. So 99 over 99, that's 1 plus 9 tenths, and that gives us 19 over 10, or 1 and 9 tenths, whichever way they ask it. If we were to go through the trouble of putting them all under a common denominator, we should notice that would have taken us a lot more time, whereas we got this shortcut because the 99 over 99 simplifies pretty easily. All right. Okay, then I want to move on. Someone asked about week 8. You guys can keep putting your questions in the chat and we'll review them. So I know you have your whole packet, so it should be easy for you to flip between them. So week 8, question number 2 in the math. Week 8, question 2 says, in the figure shown, AC is 4, CE is 5, DE is 3. And angle ABC and angle CDE are right angles. Find the number of square units in the triangle ABC. Express the answer as a common fraction. So, well, we got to draw this first of all. So, next, I would like to label the right angles. We know that that's definitely going to come in handy. And what do we get? This is 4. This is 5. This is 3. So the first thing I think that we can figure out, one second, is, where is this? The first thing that we can figure out is using the Pythagorean theorem, which I assume everyone remembers by now, right? A squared plus b squared equals c squared, right, in triangles. If they have a right angle, A and B are the two legs, C is the hypotenuse. So if A is 3, B is x, and C is 5, first of all, many of you should recognize that this is a Pythagorean triple, right? 9 plus x squared is 25. X squared is 16. So x is 4. So this now is 4. But the question is, how do these two triangles relate to one another? Well, this angle and this angle are vertical angles, so they are equal to each other. And we have two right angles that are equal to each other. So that means that these two are in proportion. Now, what is the proportion? The proportion is 4 to 5. Because what we do know, we don't know the other two legs, what we do know is that the one on the left is 4/5 of the other one. Right? So what we need to figure out, this is strange. We know that the area is going to give us base times height divided by 2. Remember the area of a triangle. So we need to figure out what the area is. Why does this say 96? Why did they give it to us as such an odd fraction? What are you guys saying here? So that means that both of the sides would be 4/5. So 3 times, right, okay, sorry, if it's 4 to 5, then let's say if we call this x and we call this y, regardless of what order they're in, x is going to be 4/5 of 3, and y would be 4/5 of 4. Is that right? So this should, I'm not sure if we're doing the right thing here, but this should give us 2.4, and this should give us 3.2. And then 3.2 times 2.4. That gives us a different answer. Any ideas here? Oh no, wait, we're right. Sorry. 2.4 times 3.2. 2.4 is 7.68. And when we divide it by 2, we get 3.84. That is, the answer that they gave us was 1 as a fraction, and they told us it was 96/25. And that is the same as what we got, 3.84. And I think that's what confused me. So just to walk you guys through this again really quickly, what are we doing here? We found first the dimensions of triangle ECD, right? Using our Pythagorean theorem, which is a squared plus b squared equals c squared. What we do is we plug in the numbers that we know in the right positions, and that's really important because the right position is that the 5 has to be C because it's the hypotenuse, and the 3 is one of the legs, and X, or what we find to be 4, is the other leg, and it doesn't matter what order the legs are in, but what matters is that the hypotenuse is always C. When we figure out that that is 4, we label that side and we have a 3, 4, 5 triangle. Next, we look at the triangle on the left and we recognize that they are similar triangles because they are both right triangles and they share this common angle in the middle. Then we figure out that the ratio between those two triangles is 4 to 5 because the two hypotenuses have a ratio of 4 to 5. So that means that the two sides on the opposite sides, AB and BC, have to also be in the ratio of 4 to 5. So they're both a little bit smaller. They are 4/5 of the other side, right? Just like 4 is 4/5 of 5. So we take 4/5 of 3 and we take 4/5 of 4. I used it in decimals. You could have done it in fractions as well, but 4/5 of each of those respectively is 2.4 and 3.2. And then we know that the area of a triangle is base height divided by 2. So we plug it into the area of a triangle. Questions on that? Sorry if that took a while. All right, and similarly, now this isn't an actual question, but someone asked us about the area of a trapezoid, and I think it's a very important formula to know. So many people say that it doesn't matter because you can usually just split it up into the triangle and the square, but sometimes it's going to be a lot faster just to use our trapezoid formula in case we're missing anything, and so forth. So if I have a trapezoid here, I want to label a couple of things. And also in the meantime, while you guys copy, if there's any questions you want to add on, I think I've covered everything you put in the chat so far. So tell us what else there is. Just be sure to specify what week and subject. So a trapezoid has to have a height. And be cautious to recognize that the height is not the same as the slanted side, right? That is not a height. The height is always perpendicular to the base in any shape. Then in the trapezoid, we have two bases. We have base 1 and we have base 2. It doesn't really matter what order you draw, which order it's in. It doesn't matter which one is 1 or which one is 2. Now, similar to how any quadrilateral would be, a square would be base times height, right? A parallelogram is base times height. Even a triangle is base times height, but divided by 2. So we're using the same principle of base times height, but of course we have to adjust it because, well, we have two different size bases. So basically, to have turned this into kind of like a rectangle, kind of like a square, how would we only get one base? Well, if we were to have one base, it would be somewhere in the middle.
It would be the average of B1 and B2.
So therefore, to get that middle base, we would have to do the average of the bases. So I would draw it out as B1 plus B2 over 2. Now this gives me an average base. And then the rest of the formula is just base times height. So average of the bases times the height. This is the best way to memorize it. If you look at the formula, it might appear complicated because we have a fraction and two bases, but just think of it as average of the bases. You have two numbers. How do you find the average of them? You add them and you divide by 2, and that's exactly where this formula comes from. So what I just keep in the back of my mind is whenever I come across a trapezoid, I just think average of the bases times the height. So let's copy that down and tell us what else you guys want to go over. We have 13 minutes left. You can jump around between the weeks, but just tell us which ones.
I have a question.
Yeah.
What happens if the two bases aren't parallel to each other? Then how would we find the area?
Then it's not a trapezoid. Yeah, then it would be some different shape and you would have to approach it differently. If you have like a weird looking shape, right, that's not a shape that we know, we would have to necessarily break it down into shapes that we do know, or maybe they'll give it to you in like a box and we subtract the outside shapes, things like that. But there's only a certain number of shapes that we have area formulas for.
Miss Dasha,
Yeah.
I need the number 3 on 8. So basically, like, I got my answer, but it doesn't match the
Number 3 in week 8 for math?
Yeah.
Okay, let's look at it. AC is 12, CD is 9, B is 3. That's cool. So they're asking us here the area of the trapezoid. So let's draw this figure. So again, we are on week 8, number 3. And everyone should be following along and drawing these diagrams with us. So we again have two similar triangles. What does that mean for us? It means that the two areas are in a ratio. So let's figure out what that ratio is. So it tells us that AC, this thing is 12. CD, the bottom is 9. And BE, this top is 3. So what do we know? The ratio is 3 to 9, or 1 to 3, because the two bases is 3 to 9 or 1 to 3. So what are they asking for? The area of a trapezoid BCDE. So all we need right now, we have the 3, we have the 9. All we're looking for is this x of a height. So what do we know? That if this top is 1, or not 1, let's use a different color and we can call it like y. If this is y, then this bottom part is 3y, because it's in a ratio of 1 to 3. So to find out what y or 3y is, we would have to do what? Well, y plus 3y we know is 12. Y plus 3y is 4y, so 4y is 12. So y is 3, which means this is 3 and this is 9. And this is the height that we were looking for, and we can check, does it make sense? Well, 3 plus 9 is in fact 12, so it does make sense that AC stays 12. So next step is our area of the trapezoid. Remember, average of the bases. 3 plus 9 is 12. 12 divided by 2 is 6. 6 times 9 is 54. So our correct answer should be 54. Is that what you got?
Yeah, I got 54, but I think on my answer key, I don't think, like, one sec. On my answer key, it says it's 48 square meters.
I thought it was 48 too, because they're asking for the area of the trapezoid.
Yeah, I also got 48.
Yeah, not for the whole
How do
trapezoid.
you get 48?
Because you subtract the triangle at the top.
Yeah, they're not asking for the whole thing.
3 plus 9.
They're saying find the area of the trapezoid BCDE.
Was I looking at the wrong thing? Sorry, let
I
me.
got 54 for my answer.
Miss Dasha, I got 54. I don't think anything's wrong.
No, because that's the whole area of the whole.
Yeah, it's the entire triangle. That'd be the area of the triangle.
Wait,
No, the area of the triangle is 9 times 12 divided by 2.
You have
The
to.
area of the entire triangle is 9 times.
Yeah,
the
but they're not asking for the entire triangle. They're just asking for the trapezoid.
Yeah, they're asking for the trapezoid that we outlined. And the trapezoid that we outlined should have the bases of 3 and 9 and a height of 9. So why should I also subtract the triangle if I didn't count it in this area?
If everything that Miss Dasha did is correct, that means the area of the triangle and the area of the trapezoid is exactly the same.
Which, the big triangle?
Yeah, the big triangle. Because it would be 9 times 12 divided by 2, which is also 9 times 6, which is also 9 times 6.
Oh, why is that?
But what Miss Dasha did, we already subtracted the triangle from the whole thing before we did the equations. So why would we subtract it again?
You guys are raising a very good point.
But I don't think like the trapezoid is even a triangle because it's far-sided figure.
But if we were to take the big triangle and subtract the small triangle, the big triangle is 54, right? Because we did the 12 times 9. CD is 9, B is 3, right? 3 times, and then the small triangle would have been 3 times 3. And that would have been 9 divided by 2 should give us 4.5. So by that logic, the trapezoid would have been like 49.5.
Well, that means the first method doesn't work or something? Because
Something's not adding up. It's okay, you guys are raising good points here. Something doesn't make our trapezoid is the same as the triangle.
We had to do 54 minus 6 to get 48.
Why would we subtract 6 though?
I think the ratio of you put 3 to 3y, I think that's incorrect. Oh, I get it. I think it should be 4 to 8. It's because 9 times 54 equals 6, and then 54 minus 6 equals 48.
Why would you do 54 divided by 6, divided by 9?
So I did 1/9 times 54. That
Why
equals
multiply
6.
by 1/9? That's what I'm asking. Why multiply by 1/9?
I thought it would be a way, because it ended up with 48. What is the answer?
Well, we can also get 48 by doing 47 plus 1, right? But that doesn't exactly explain the numbers that we're using here. This is definitely something I want to look into.
yeah, because like methods, we all used the methods, but we got different answers. But like, which one's the correct one? Because I think all of them make sense.
Yeah. You kind of got me there. It might be that could we be doing something wrong with the ratio maybe? Is probably where we're wrong. But I would definitely have to take a closer look at it. Who got 48 and can tell us what they did like start to finish? To see if there are other methods. Anyone?
Miss Dasha?
Yeah.
I didn't get 48, but I do have a question. What does the answer key say?
The answer key says 48.
It does?
Yeah. That's why I'm stumped, because we got 54. It seems like we did everything right. But someone brought up a good point, though, that 54 doesn't make sense either, because if we just take the area of the big triangle, we get that the big triangle alone is 54. So you can't have the trapezoid be the same as the whole triangle. And that makes sense to me. 3 plus 9.
I think that the side where you put 3 equals y, I think that should be 4 because it's a 3, 4, 5 triangle.
We can't assume it's a 3, 4, 5 triangle.
It has a right angle and it has 3.
That doesn't mean it could have been a 3, 3, 3 root 2.
No, they're the
Oh
same.
yeah.
The corner is a right angle. The top, they share the same one, so that's the same. And the bottom is 9, so it's 3 times as big as 3. So it's the same, but the angle is still the same as this trapezoid's angle up here, and the smaller one up there.
So if this were a 3, 4, 5, right? Then that would mean that this side would have to be 10 and this side would have to be 8, and that wouldn't make sense. Or would it? Cool. Could that be? Well,
I
let's see.
think I know how they got 48.
If we do 12 times 8.
I think I know how they got 48.
Oh, wait, hold on. Is it this method? If we say that this is 8, if this is a 3, 4, 5, and this is a 9, 8, and then this is 15, then this would work. If our height was 8 instead of 9, you would have 3 times 9 is 12 divided by 2 is 6, then you would have 6 times 8 is 48.
Since 9 is 3 times as big as 3, then 12, then this side of that small triangle on the top will be 4. So then 3 times 4 divided by 2 will be 6. So 54 minus 6 will equal 48. So the answer, so the trapezoid is 48 square. It was square. Sorry. Square centimeter. Wait.
Oh, you know what? I found out what we did wrong. Sorry, if you guys have to go at exactly 4, you're free to leave. I figured out what we did wrong. The ratio, we were right. The ratio is 3 to 9, or 1 to 3. But the ratio is between the small triangle and the whole thing. Which means that it's not 4 to 8. We should be looking at it as 4 to 12. If the small triangle, if the big triangle is 12, right? 1 to 3 should be x to 12, and that would be 4 to 12. So the height of the small triangle is 4, which means that the bottom side is 8. And that's also why the small triangle, the big triangle was x to 15, because it's 9 and 12. So that means it has to be 5 to 15, and that's how we get that 3, 4, 5 triangle, and that's how we get the 8 for the height of the trapezoid, and therefore it is 6 times 8, and that's 48. Does that make sense, or should I rewrite this?
Oh, I get it.
The point that we missed, by we I mean I, was the ratio isn't between the top and the bottom. The ratio is between the top and the whole. So we were wrong I was wrong over here when I said it was 3 to 9. It's actually 4 to 12, because that's the 1 to 3 ratio, the small to the big. And that's what I want you guys to correct in your notes. Good question. I'm glad that we were able to solve this as a group. I have to let you guys go. It's 4 o'clock. So if you have any last minute questions, you can stay back a couple minutes. But otherwise, you're free to go. And I look forward to seeing you all next Friday.
Bye. Bye.
Bye.
Bye.
Bye. Bye. Bye.
See you next Friday.
See ya.
I get it. I get the problem.
Good. I'm glad that after everything we were able to figure it out.
It's because S triangle ABE over S triangle ABC equals 3/9, 2. And then that S triangle DEC equals 3/9, 2. S triangle ABC equals 1/9 times 54 equals 6. So that's how we got the 1/9. And then 54 minus 6 equals 48.
Yeah, you could do it. Yeah, that's a different way of doing it. But yeah, you're absolutely right. It also works. Nice. I'm glad you figured out an alternative method. All right, guys, so ask questions or log off because I want to close down the whiteboard. All right, guys, if you have no other questions, I'm going to end this meeting.